Hello, so today I was going to start with some work on surds. We're going to be looking at simplifying surds, which is largely multiplying and dividing. However, to start with, a surd is basically a square root that we cannot resolve. So if we were to take the square root of 16, this is not a surd. We are able to express that as 4. 4 squared is 16, the square root of 16 is 4. However, so that is not a surd. Surds are square roots of things like 5. Now, if we were to put the square root of 5 into a calculator and hit equals, it's going to tell us it's the square root of 5. We could obviously press this button here and it'll turn it into a decimal. The problem is this decimal goes on forever. It's like pi. It's an irrational number, goes on forever, doesn't repeat. We can never write it down. We can have a good go, but we'd be going forever. So if we were to start writing it down and then calculating with it, doing things with it, and surds are useful, they do appear quite a lot in real life, we're introducing an error which might end up getting compounded. So we have to be able to work with surds in their form of square roots. So it's a little bit like index laws. Once you know how to work with them, you just apply them and it's all good. So the first thing you need to do is be very comfortable with recognizing your square roots. So we have, and if you're not sure, you can just write them down. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. And you can keep going. It's 5. So you can write all those down, but you have to be able to recognize them. Then do this video in a few steps, so we're just going to concentrate on the basics today. We have, the first thing we need to know is the square root of a surd multiplied by a square root of the same surd, so it's root 5 times by root 5 is 5. Or we can go the other way and we can say 3 is root 3 times by root 3. They're the same thing. Again, if you don't want to believe me, put it in the calculator and find out. The reason is, if you know your indices laws, square root we write as a half. So if you have 5 to the power half times by 5 to the power half, we know from indices laws to get this index over here, we add them, and half plus a half is 1, and anything to the power 1 is just the same thing. So that's why that's the case. So this would be first thing to realize. The next one is we can, a bit like when you're decomposing numbers, prime factor trees, you can have, so say if we had the square root of 5 times by the square root of 2. We can put them together under one square root. 5 times by 2, so that equals root 10. This is the second thing we're going to work, but again, we need to go the other way. So if we had, actually let's do the square root of 12. We can split that into root 4 times by root 3. We could just write that again like algebra, xy is x times by y. We can drop the times, root 4, root 3. Now root 4 we can recognise from over here is 2, so we can change that to 2 root 3. So we're going to do a little bit of practice with that. So I'll get a new piece of paper. And we will try a few of these. So the first one you might be asked to do is you're given a surd and you have to basically simplify it as much as possible. So if we do a couple of examples, root 8. Now I know that root 8, or 8 is 4 times by 2. So I can change this to root 4 times by root 2. And root 4 I can recognise as 2. So root 8 we can write as 2 root 2. Again, now you need to be able to do it without the calculator, but you can use the calculator to check. One more example of that type, root 48. So I know, and it doesn't matter which way you could go, you could pull out root 2, you can pull out root 4. Again, check that, go two ways and you should end up with the same thing. So we've got root 4, root 12. Now the root 4 I can change to a 2. Root 12 I can change to root 4 times by root 3. Then that root 4 is 2. So I can have 2 times by 2 times by root 3. And I know that 2 times by 2 is 4 root 3. So that's one type of question. You may be asked to go the other way and in effect be given the answer and go to a single surd. So for instance, if we have 3 root 2, I know that 3 can be split into root 3, root 3. Root 2 sits on the back. Then I put them all under one square root. 3 times 3 times by 2. 3 times 3 times 2 is 18. One more example, 15 root 6. So the 15 I can split into, this way I'm going to split this into a slightly different way. I could say with this one, is it worth going that way? Yeah, I could say, no, I'm going to stick with the normal way actually. We might cover the other way tomorrow. Root 15, root 15, root 6. Then I can put all this under one bracket, or one square root. And at this stage, I'm going to bring in the trusty calculator to do 15 times 15 times 6, which gives me the square root of 1350. And if I put that in, 1350, it should take me to 15 root 6. So again, that's a way you can check with your calculator. Another type could be if you're just given simply root 3 times by root 6, 3 times by 6, root 18. So that's another little type. Then we've got where they'll bring in extra numbers. So we've got 2 root 7 times by 4, root 3. So on this one, I can treat the numbers kind of separately. So I can do separately 2 times by 4 is 8. And then this one, root 7, root 3, becomes root 21. Final one is we can bring in division. So if we've got 6 root 15 over 2 root 3. Again, just like algebra, we kind of treat these a little bit separately. So ultimately we're going to do 6 divided by 2, which will be 3. But to start with, I'm going to break this one up into root 5 root 3 over 2 root 3. And then I can see what's going to happen. 6 divided by 2 is 3. Root 3 divided by root 3 cancels to leave us with root 5. So that's all we're going to cover today. So as a quick recap, we have learn your square numbers. These two rules are the only two we're pretty much using today, but in a lot of different formats. Cool.